This section is rational exponents. To begin with, we are going to go ahead and review our rules of exponents. So first off, when we multiply bases, we add our exponents. When we have a power to a power, you multiply your exponents. When you've got a product to an exponent, both factors will get the exponent. When we've got a fraction to an exponent, both your numerator and your denominator get that exponent. Anything to the 0 power is 1. When we've got division of bases, you subtract your exponents. When you've got a negative exponent, it goes to the denominator, your exponent becomes positive. And if you've got a negative exponent in the denominator, it moves to the numerator and also becomes positive. Alright, so notice two things here. Using our rules of exponents, it's a power raised to a power, so this would be 5 to the 2 times a half, well 2 over 1 times 1 over 2 is 1, so 5 to the first power, which is 5. But we also want to think, what squared is 5? Well, what number, when we square it, gives us 5? And the answer to that is the square root of 5. And that's because if we were to have the square root of 5 squared, that's the square root of 5 times the square root of 5, which is the square root of 25, which is 5. So what this tells us is that 5 to the 1/2 is the same thing as the square root of 5. So we're going to use this idea. So anytime we've got x to a fraction exponent, whatever number is here in your denominator, it's that root that we're looking at. So for this first one, that's 16 to the 1/2, that's the same thing as the square root of 16, which is 4. This second one, this is the cubed root now. So cubed root of 27 over 8, which is the same thing as the cubed root of 27 over the cubed root of 8. So think about what cubed gets us 27. Well, that's 3. And what cubed gives us 8? Well, that's 2. This last one, it's to the 1/4, so that's the 4th root. So this negative will stay outside, 4th root of 16x to the 4th. So this negative 4th root of 16 is 2, and then the 4th root of x to the 4th is the absolute value of x. So now we're going to go the other way. So this whole thing is under the root, so it's going to be this whole 4ab to the 1/6 root, or to the 1/6 power. Notice in this second one, though, only your x is under the root. That means only this x has the 1/2 power. That 3 was in front of the root, so it doesn't have the rational exponent. Now another thing, notice if we have 5 to the 2/3, we can rewrite this as 5 to the 1/3 squared, which is the same thing as the cubed root of 5 squared. But we can also write it as 5 squared to the 1/3, because a third times 2 is the same thing as 2 times a third, which is the same thing as the cubed root of 5 squared. Notice these two are the same. It doesn't matter how we write it. So on this side, doing the same idea, we can write this as 4 to the 1/2 cubed. Well, 4 to the 1/2 is the square root of 4. Square root of 4 is 2. 2 cubed is 8. Or we could have written it as 4 cubed to the 1/2. 4 cubed is 64. And we still have to the half, which means the square root, which is 8. So it doesn't matter which way you do first. Typically it's easier to do the roots first, but that doesn't always work. So this is telling us what we just were figuring out. It doesn't matter whether we do the root first and then take the exponent, or do the exponent first and then take the root. So for this first one, 16 cubed is going to be a large number. So let's go ahead and do the square root of 16 and then cube that. So the square root of 16 is 4. When we cube 4, we get 64. Now this one is going to be easy if we look at the cubed root first. But we still have this whole thing squared. So let's look at our cubed root. So we still have this whole thing squared. Our cubed root of negative 27 is negative 3. Our cubed root of x to the 6 is x squared. And now we just need to square both of those. So negative 3 squared is 9. X squared is x to the 4th. Now it's the same thing, but notice we've got this negative here. This negative works the same way. It just moves everything to the denominator with that exponent. Now notice our exponent is positive 3/2. So let's go ahead and take care of this half, which means square root. Square root of 25 is just 5, but we still have our cubed, so 1 over 125. Now this next one, same thing. Let's go ahead and take care of this negative. So we'll have 1 over this negative 27a cubed now to the positive 2/3. Once again, let's go ahead and do the cubed root. So the cubed root of negative 27 is negative 3. And the cubed root of a cubed is a, but we still have all of this squared. So we'll have 1 over 9a squared. Now this one, we will have 1 over negative 16 to the positive 3/4 now. And so let's go ahead and take the 4th root of this. So that would be the 4th root of 16. Sorry, negative 16. Well, that's not real, so we can't do that. So we still need to pay attention to if there's a negative in our roots. Now this one, it looks different, but remember when we've got an exponent with a product, this exponent is actually going to multiply to each of them. So we'll have x to the 1/3 times 6, and then y to the 3/2 times 6. If you want 6 over 1, on this first one, this will become a 1, this will become a 2, so we'll get x squared. Here this will become a 1, this will become a 3, y to the 9th. Same thing here. Our bases are getting multiplied, so we will add our exponents. So we'll have x to the 7/3 over x to the 1/3. And now remember, when we divide, we want to subtract our exponents. So we'll have 7/3 minus 1/3 is 6/3, which is 2x squared. This one, now we just need to distribute. So we'll have p to the 2/3 times p to the 4/5. And remember, when I'm actually just going to write it the long way first. And then we'll have minus p to the 2/3 times r, plus p to the 4/5 times r to the 1/3, minus r times r to the 1/3. Now when we multiply bases, we want to add our exponents. So here we'll have 2/3 plus 4/5 common denominator. Now these middle two, your variables have different exponents, so we can't combine them. They are not like terms. And then this last one, there's an exponent of 1. So we'll have 1 plus 1/3, common denominator of 3. One thing to note here, you do need to leave both of these exponents here and here as improper. If you were to write the exponent as 1 and 1/3, it loses meaning as far as roots. So you do need to keep them as improper fractions. And that is the end of this section.